Mm-hmm. Yeah, okay. Yeah, just trying to sort out the projecting. Um, okay. Okay, don't know. I didn't know.
Would you mind connecting?
Okay. Okay. Okay, good morning, everyone. Sorry, I was just talking about the screens in the classroom. Thank you for coming back. This is week 4, week 3. Week 3, sorry, week 3. Orientation week. Today we're talking about how to make statistical graphs using RStudio. We have 2 weeks for this topic. So today we talk about how to make some graphs using ggplot2 package. Today is about histogram, box plots, and then density plots. Now, ggplot2 is the package we need to use this semester in SED 113. And it's very, very powerful, very, very useful package in R. People use a lot to create data visualization. And data visualization is a bigger concept than statistical graphs. Okay? There are different types of data visualization. But today we just focus on statistical graphs. Yeah. So first of all, what is ggplot? GG, we know plot is a graph, right? And then plot2, I guess there was a previous version, ggplot1, I don't know, maybe. Then GG is a grammar of graphics. Grammar of graphics. And I just sent you a copy of the slides. If you have already registered, and just a PDF copy. Yeah. Grammar of graphics comes from the book written by this person. And then there are 2 editions of the book. I think they are open source. I know you can try to search for the book if you want to read. You can. But we just need to know that GG stands for grammar of graphics, and for grammar of graphics, they put things into different layers. All right. We organize the elements of a visualization or a map or graph or whatever visual output. We organize things into different layers. So data is the foundation. The information from the visualization from the data, and then you have to define the ethics, which variables to use, okay? And then the geometry. You want a chart, you want a line, you want a dot, or you want the shape. Okay, whatever geometries you want to use to represent the data, you can use more than one geometries on one graph, that's okay. We're going to do that today. Okay. And then there are other layers you can put on the color, whatever, okay, font, and background color. So we organize things into layers. And there's a link to a short video talking about the GG, and also there's a book, ggplot2, an open access book. I have a link in my presentation. You can have a read if you like. Okay, today's agenda. We focus on how to visualize. Suppose you have a statistical question. Okay, you want to compare the quantity of a numerical variable between groups. Okay. So, for example, you want to compare the blood pressure between people in different age groups. Okay. Suppose that's the data we have, and then you can probably use some of the plots we have. We're going to demonstrate today. Okay. So basically, today's graph focuses on the relationship between two variables. One is numerical, the other one is categorical. Okay, and then we focus on three types of plots. The first one is a box plot or box Whisper plot. Second one is histograms, and the last one is density plots. Some people call kernel density or density plots. Doesn't matter, mean the same thing. Okay, yeah. So we're going to learn the details in a second. And by numerical variable, I mean the variable which is on a ratio scale or interval scale, or it's a count of objects. Okay. Categorical variable, I mean the variables on a nominal or ordinal scale. Okay, like an age group is an ordinal. Okay, and gender groups, gender is a nominal variable. Yeah, a scale. Okay. All right. Well, let's go to the details. So first of all, the data we are using today is the data we used. I think we used it already last week. It's called the Gapminder data, which is a longitudinal data set. It records the population, GDP per capita, and the average life expectancy of 142 countries from 1952 to 2007. So these four variables, population, GDP, life expectancy, these three variables, they are recorded every 5 years for each of the 142 countries. And then if you haven't installed it, you have to install this package, Gapminder. And if you have already installed it, just load it by running library Gapminder. Okay. And then we need a copy of the data frame. Okay, I just create a new object called a GM, which is just a copy of the Gapminder dataset. Okay, and then if you run summary Gapminder, that's the command we learned last week, how to get a summary of the variables in the dataset. You will get a summary of all the variables. Okay. And we also need ggplot2, obviously. ggplot2, that's the package, that's the start for today's session and also next week. So if you haven't installed ggplot2, please install ggplot2. Don't forget the 2, okay? Otherwise, you don't install the right package. And then after installing it, load ggplot2. Library ggplot2. And also, again, we need to use the tidyverse package again today. So we also have what we call the tidyverse. All right, so I'm going to run the same thing. All right. RStudio. I'm running my RStudio, and it's a bit slow today. What's going on? Right, there's the stuff I don't need. Just delete them. Okay. Open a new file, RScript, and so I need the library Gapminder. I also need a library ggplot2. Yes, and also library tidyverse. Because I have already installed them, I get a hint when I start typing those names. All right, and then library all of them out. I get some warning message in the console to just remind me of the version of those packages I installed. A little bit old. That's okay, and then have a try. So if I have a copy of the data GM Gapminder, I get a hint. Yeah, that means I got a hint of this data frame. That means I've already loaded the Gapminder successfully. Okay. Control Enter. Okay. I just created a copy of the data set. Gapminder in my memory is called a GM. That's the name of the copy, and then it has a 1704 observations and 6 variables. So why it has about 1704 observations? Remember, I have 142 countries, and then each country has 12 measures, because each country is kind of surveyed every 5 years over 60 years each. So every country has 12 reports. And then we put data in a long format. If you remember last week, you have a longitudinal data, you can organize them into either long format or wide format. Currently, this is long format. So we put the multiple measures of one single country into multiple rows. So we have 12 rows for each country. So 12 times 142, I guess, is 1704. Oh, let's check. Why not? They have a calculator here in RStudio, right? RStudio itself is a calculator. So if I go to console, that one is so big. This one? Yeah. Yes, I'm not there. Yeah, 142. 142. Yes. So, thanks for that. You see, I'm learning everything. I'm learning something every day. Yeah. Okay. Now, you know that in R base functions, there are some plotting functions we can use to create some basic plots like this one. If I want a box plot of life expectancy across different groups of continents, I can run this single piece of comment, this one. Okay. I put R command. If I go to R, and then if I run this, box plot, that's the function in basic R, remember? Okay, and then the variable I want to plot, the quantitative variable is life expectancy in the Gapminder in the GM dataset, the copy of my copy of Gapminder, and then across this categorical variable continent, because continent is a categorical variable here. Asia, Europe, Africa, Americas. So if I run this one, there's error. Trigger margin is too large. That means because the graph is supposed to show up at the bottom right corner. If the corner is too small, you may get this error. So I just need to make the column a bit larger. Okay, and then run again. Yeah, okay. Yeah. Now I can, with the last time, you can export that. You can adjust the ratio before you export that. Oh, right. I want to make it order before, sorry. It doesn't look too bad, you know. If you're happy with that one, you can just copy the block, and then it's copied in your clipboard, and then go to your Word document, and then Control V or paste. You get a graph copy. It doesn't look too bad, okay, to be honest. For the box plot, is if we compare the life expectancy distribution across these 5 groups of continents, okay? And then box plot is used. So here we have a 5 box plots. So it's strictly speaking, this is a group of side-by-side box plots. Okay. Every single box plot is used to demonstrate the distribution of a numerical variable. So where the values are and how frequent they are. So box plot is constructed based on the 5 important statistics: the minimum, maximum, Q1, Q3, and Q2. Q2 is also called the median, right? So this is the stuff in the lecture, so I don't want to repeat too much on that. But we are not going to do that today. We are going to use the ggplot package to make a more impressive videos. Okay, the first one is this one. You can have a try. So the first one is we're going to plot the same plot, but this time we can modify the color. We can add some points to show the locations of the data. I know this one was bit ugly. We can modify that. So all right. So I'm lazy. I just copy this. So Control C and go to my all right. You can see I'm one the type operator. So first one, this is my data set I want to use. It's GM. This data set, a copy of get minor data frame, and then I'm going to use ggplot, and then the ggplot function, you have to tell the computer which one is the x variable that's continent, and then which one is the y variable that is life expectancy. Okay, and then you can choose to fill the graph according to the variable. Okay, so I'm going to fill that continent. And in ggplot, remember ggplot is a grammar of graphics. We combine different elements of the video according to layers. So how to combine these layers? You use a little plus symbol here. Okay, so add one more layer. So in this layer, we tell the geometry we are using. Okay, we're using the geometry box plot. Okay, and then I'm going to add one more geometry. I'm going to add the jitters. Jitters are the I'll show you if I run this. Take a while. The jitters are the black dots. It looks a bit scary. Yeah. So why do I want to show this graph to you with the jitters? Because I just want to give you one message. Now, the box plot, every single box plot is graph based on minimum, maximum, first quartile, second quartile, also called median, and and third quartile. Now, between two data sets or multiple data sets, they can have the same numbers or same values for these 5 important statistics, but the distribution can still be different. Okay, so for example, these 5 groups of life expectancy, they can have the same Q1, Q2, Q3 minimum, maximum. And if you just request box plot, you will see the same 5 box plots. But the details of the distribution between those 5 values can be different. So if you want to see that details, you can request it. You can put the jitters on that. Yeah. So the limitation of box plot is that it shows the 5 important statistics, Q1, Q2, Q3, minimum, maximum, very clearly. But the disadvantage is it doesn't show the details of distribution. Okay. We're going to learn how to use histogram and density plots in the second half of this workshop. The histogram and density plot, they will show more details of the distribution. Okay. Yeah. So you can black box, if it's very dense, then means the more data is in those areas. If it's very sparse, that means that there are less observations with values in that area. So here, this one, you can see it's very dense here. That means in Africa, most countries, and then in those years, their life expectancies are around like 40 to 50 years old. And then not many are about 70, because very sparse here. But if you look at Europe, it's very dense here. That means most countries, and in those years, their life expectancies are around 70, 75 years old-ish, but not many in the lower end. But obviously, this graph is not perfect. It looks a bit ugly, right? All right, a little modified. Any questions for people online? Okay, anyone online? Any question online? All right, next one. Next one is I'm going to modify it. So how do I modify it? I'm going to again, I'm going to use box plot to illustrate distribution of life expectancy again, and I'm going to compare between the 5 continents again. But this time I only want I'm going to add one more variable, that is year. Okay, so whenever you are trying to make a graph to explore your data, or make a graph to explain your data to your audience or readers, you have to have an idea in your mind first. So what you are trying to get, and then you implement your design, your man, with the codes or in whatever other package you are using, right? You have to have something in mind. So I'm going to compare the life expectancy across 5 groups of continents, and also I'm going to compare across the 3 years. I'm interested in 57, 87, and 2007. So how do I do that? Again, this is my data set, GM, and then I'm going to choose because my data is in long format, different years in different rows. So I'm going to choose the rows that have year in 57 or 87 or 2007. So remember in Tidyverse language, how to choose the rows you are interested in? We use the filter function, right? Filter is for choosing the rows in the spreadsheet. Select is for choosing the columns in the spreadsheet, right? Yeah. So we're going to filter and keep the rows which have year value as 57, 87, or 2007. That is the command, the highlighted part. Okay. Okay, and then I'm going to use ggplot again. Again, X is a continent, Y is life expectancy, And this time I'm going to fill the box plots by the value of year. Now for the field bit, you have to fill a variable. You have to fill them by a categorical variable. Year at the moment is not categorical. If I go back another, year is in terms of it's kind of quantity. Yeah, so if I check the type of year, remember how to check the type of a variable? We learned 2 weeks ago. Can use the class function. Class dataset name, dollar symbol, variable name. It's an integer, so it's a numerical variable. Yeah. So if I put a fill by year, you get an error. You have to fill something by either a factor or a character variable. So in previous slide, we filled the box by continent. Continent is okay because continent, I believe it is a character variable. We can double check. I think continent is a character variable. As a factor, oh, that's good. Okay. So by writing factor and then brackets here, I'm kind of converting the value of years as a factor levels just for the field bit. Okay, and then I'm going to add the geometry, which is box plot. And if you run this piece of code, you should get this one. Okay, I'm pretty sure my code's okay because I tested the day before. Let me do it again. Who knows? Everything can happen when you are dealing with computers. Right, let's go. Run. Yeah, it is draft. Be careful. Pay attention to this one because now we have 3 variables in one kind of grouped box plot. Okay, we have the focus variable is life expectancy, which is numerical. The grouping variable is continent, and we also have one more variable that is year. So I have 3 variables in one graph. You get more information. You can see that on average, or generally speaking, Oceania and the European countries, and some Asian countries, to be honest, except for African countries, the other continents, they have a higher life expectancy, around 70 or 60, 70 years old. Right? But obviously, the distribution is wider in Africa's and the Asian countries because the range is very wide. In Africans, on average, it's kind of high, but some are very low, some are high. Also in Asia, on average, it's probably not too bad, 60 years old, but again, the distribution is very wide. The spread is very wide. Because we know some countries are very poor in Asia, and some countries are very rich in Asia. Asia, I guess here, including the Eastern Asia, all the way up to the super rich Gulf countries. Right, so the distribution of GDP is very wide. And then, but if you go to Oceania and the European data, they are on average very high, on a high level, and also the spread is very narrow in terms of life expectancy. And if you go to Africa, the spread is also a bit wide. And we can see the good thing is generally as time goes by, the health level tends to increase. If we use the life expectancy as a proxy of general population's health level, so it's that's the good thing, right? In the last 50 years, half century, people's life expectancy increased a lot. Okay. That's good. All right, so that's how you can whenever you make a graph, you include a graph in your report or in your presentation or in your article or in your thesis, you have to talk about it, right? Otherwise, don't include a graph. Right? And then if you don't talk about, people will question why this graph is here. What's the point? Because you are writing a paper for people to read. You're writing a report or thesis or article. It's supposed to be read by the readers. Paragraph by paragraph. And then you can refer them to your graphs or tables. I mentioned like table 1 shows the distribution of the box plots in figure 2 and illustrate blah blah blah. Okay, so we have to talk about the exhibits, tables or graphs or visuals in your writing. And then if something that are too big to be talked about or included in the main body of the text, you can put them in the appendix or somewhere in the end of the report. All right. Again, this graph looks better, but I'm still not happy with the details. Like for example, something like this label here, legend, can be modified. Okay, and also the axis label they are not very meaningful, so we can improve that. Next one. So this one, what did I do? So this one, I fixed the label. So I call it year this time, year, not factor year. And then I added jitters, just for fun. And then I make the background black and white because by default, the background in ggplot is a kind of a gray color. Like the previous ones. So I make it black and white. And then also I fixed the axis labels. I'll fix next one. Yeah. So just we fix some things here. Okay. So how to fix the label of the field legend? You use this one, LABS labels, and then field equal, and you put whatever name for the legend you put in a pair of double quotation marks. And then I add a geometry of points. So I put the points here. As a designer, you can decide to put the points or not. And then this is to make the theme black and white. So THEME underscore BW, black and white theme. And then the other thing I want to mention here is when you are adding a geometry, you can adjust the transparency of the feeling using the alpha. So if the alpha is 0, that means totally transparent. And if alpha is 1, it's totally solid. So I put alpha equal to 0.3. So my points here are kind of a half transparent. Yeah. Question?
So let's see making that vector.
Which one?
Here, like in that C in those 3 values in vector.
Yes. Yeah. This one is the C function is a function to combine things into a vector. We'll talk about this in future week when we're talking about the programming basics. Yeah. But we have seen this one a few times, the C thing, today and also in previous weeks. I remember in the week we talked about recoding a variable into a vector. In that week, I can't remember. Yeah. But this is the C function is to combine things into a vector. All right. Because I have 3 years to choose. If I only have 1 year, I just use year equal to 2007. But I want to choose 3 years. I'll do 3 years in one piece of code and make them into a vector. Yeah, good question. Right. But this one again, is working. It worked. You can always export your data as a image file if you like, or even PDF. Maybe I need to remove the points. Doesn't look too good. All right. Now, next one. Next one, I'm going to do something different. So you will use this one quite often. The reason is I want to see the change in all the 12 years. Okay, not just 3 years. So I'm going to use the facet wrap in ggplot to make a series of tiny plots in one big plot. So I'm facet wrapping according to year. That's the line for facet wrap squiggle year. Okay. So I have 12-year values. So we will have 12 tiny plots. The first value of year is 1952, and then 57, 62, 67, all the way up to 2007. So I have 12 values in year, I have 12 tiny plots. And then in this plot, I also fixed the label, the X label I called continent, the Y label I called life expectancy in terms of year. And then also adjust the angle of the horizontal.
Syntax, does the tilde mean why?
This one?
Yeah.
It's just the syntax for the red part. Because the tilde can mean different things. Yeah. Remember the first graph here? We have a tilde here. Yeah. So tilde in different contexts means different things. And then in future weeks, you will learn regression modeling, and the tilde is used to connect the dependent variable y with a bunch of independent variable x's. So tilde can mean different things in different contexts. Yeah. Well, that's language, right? That's language, kind of messy. But to be honest, learning a computing language is much, much easier than learning a natural language. Right? So if you compare learning R with to learning like Japanese or Chinese or German, German is quite structured. But if you like French or something, natural language is very has lots of variations than computer language. Right? That's kind of off topic. Yeah. So again, I'm going to run the code as well on my machine. Make sure it's running. Yeah, I don't know why my computer is a bit slow today. Yeah, but, yeah, it's very small. It's very hard to see, and so maybe you have to explore and then have a look if it's okay. I probably should remove the points here. Just the points doesn't look very good. The jitters, yeah. Yeah, jitters. Yeah, I will show you a funny picture before the second half to tell you what I meant before. When you are comparing the data, or when you are exploring data, we should always be careful with using the summary statistics, because the summary statistics only tell you the summary, tell you something about data, but not everything. So two data sets, they can have very different distributions, but exactly the same summary statistics, mean, standard deviation, median, quantile, whatever. But if you look at the distribution details, they can be very different. And the box plot is just a visualization of the 5 important summary statistics. It's not it's not perfect, but it's very commonly used in the literature. Okay. All right. any questions so far? Feel free to ask me or Lydia, please.
So I would just give a few aesthetic tips.
Yeah.
Because they give you extra like marks for that in assignments and things. So the first thing you want to think about, of course, is what you're trying to convey, because ultimately this graph and this graph tell very similar stories. They're comparing different years and the different continents as well. So you want to think about what are you trying to get, because you want the graph to be basically readable without reading your assignment or your report. So you want to, the first thing you want to think about is what's the important information there. And then once you've got it in the format, so do the basic code like this to get it in the format you want, then you want to start thinking about making it visually aesthetic and beautiful, which I would say these are like almost there, but maybe not quite. So firstly, the theme aspect. There's a lot of different themes, so look into those. You can just go ggplot2 theme. So they have everything from like minimalist theme or like environmental theme. So you can just apply the same theme to all of your graphs in your report and it'll be very consistent. Otherwise, if you want a little bit more control over what you can do, you can control all these elements individually. So your borders, your shading, everything like that. It's very easy to just Google how do I change X in ggplot2. So I recommend putting aside, like if you're putting aside a day to do the baseline coding, then put aside an extra day to do the aesthetic parts. And just a little tip, all the colors, you can either look up ggplot2 colors and there's a massive list, or there's something called coolers.co. It's like colors, but it's cool. And it gives you like palettes. And ggplot accepts RGB and your hex code, so your hashtag things. So you can have a lot of control over color. You can import the colors then into your like Word doc, or if you're working in LaTeX, you can use the same thing and you can have like the same colors in your graph as you're formatting, and it can just look very coherent and professional. So recommend spending time on that.
Thanks, Lydia. Yeah. That's if you do that, you definitely get you're aiming 7. But again, just introducing the ggplot2 guys. We just open a window. There's a new word behind the window. Lots of things you can control. You want to know more details. Of course, you can Google. You can also read this book, this one, ggplot2, all the details of this package in this book. But again, in SCD113, that's beyond the scope of these SCD113 guys. So if you can get something like this, that's probably enough. Get us 6%.
The baseline code. So if you get this, it's always just pluses from here on out. So you can't ever break it. It's really easy to edit it.
Yes, we start from something small to grow something big. Something. All right. I've got a picture here. I just remember I have a photo of the picture I want to show you. This is the picture I always have. It's kind of a GIF I always include in my presentation or lecturing about data visualization or statistics. It's from a conference paper by the author. If you Google dinosaur plots, you can find the original conference paper. And then in that conference paper, they use, obviously, kind of looking at R, they use R code to show that it's very important to visualize your data or visualize the data using different graphs from different angles, because the summary statistics can be very deceiving or misleading. So in this GIF, you can see we have quite a few different data sets. And if you visualize them using scatter plot, the XY plot, we see different patterns. Right? That means they mean different things. But if you just look at the mean and the standard deviation of each of the two variables, and then also if you just look at correlation, there is no correlation in the lecture, or you will definitely, if not this week, maybe next week. But if you look at the summary statistics that were commonly used, they're almost the same in the second after the second decimal. Right? So basically, the message is don't just use the summary statistics, but also visualize your data to see the details. Okay, then we can continue. Okay, yeah, then we probably finish early. All right. The next one is histogram. Histograms, almost the same purpose as a box plot. So one histogram is used to also illustrate the distribution of a numerical variable or quantitative variable. So here, this time we do the same thing. So we're going to compare the distribution of life expectancy across 5 continents. So you can see I have 5 histograms here. It looks a bit busy, this graph. I have 5 histograms. I overlay them on top of each other and then color them using different colors. It's probably not the best option here. Maybe you should think about plot them separately, each histogram for each continent, and then place them side by side. Or maybe facet wrap by continent. So you have 5 histograms separately. Yeah. I just want to show you that you can overlay histogram into one graph. And this time you see, when I'm choosing 2007, you can either do this, or you can either just write year equal to, this is logical equal, year is 2007. Yeah. And then the geometry for histogram is for the geom underscore histogram. And then when you are designing histogram, you can control the bin width. Bin width is the interval of each bin. And then alpha is to control the translucency of the filling in the bin. Yeah. So let me have a click. Run. It runs. Now remember the logic of histogram. We want to see the distribution of value of a numerical variable. So we want to see how frequent this value is. This value is shown in the data set in this variable. So how do we do that? We can group the range of value of this variable into different groups or bins. Okay, for life expectancy, it could be somewhere between 20 years old to somewhere 90 years old. So how do I see the frequency of the values? And if you see the frequency of each single value, that's probably too detailed. So we can create age groups every 5 years, every 10 years, or every 20 years. Okay, so in this graph, I'm actually grouping the age by 5 years. Okay, and then we count in the data set. We count how many observations are in each age group by 5 years, and then those counts we call them frequency of each age group, and then we plot the frequencies of the age groups using bar chart, and then remove the gaps between the bars. That becomes a histogram. And I do this one here for each continent separately. Yes, that's the logic of histogram. So for the histogram, you are not what my interest in is the shape of each histogram, the skyline. So where the bars are high, where the bins are high, that's the frequent range. Like for this graph, the high bars or high bins are around 70 to 80 years old. The low bars are around 40, 50 years old. But the distribution is different in different continents. Okay. And then kind of a competitor or alternative to histogram It's called a kernel density plot or density plot. So basically, we can use a computer to estimate the density curve of each numerical variable. See? So because for numerical variable, we treat it as a random variable in statistics. And then we can calculate or estimate the distribution density function of a random variable. So the algorithm is a bit more complicated than histogram, but we don't have no details. It's in the book if you like. You have to Google. The kernel density algorithm is a bit more complicated than histogram. Histogram is very simple, dividing the range into groups and then count the group frequency and plot the frequency by the beams or bars. But density plot is a bit more fancy. It shows more details, I think. It's getting more popular. Since we have a faster computer these days, why don't we choose the more advanced technology? The traditional graph, like a histogram and a box plot, is still show a lot in the literature. Even the modern literature, they are used a lot. Okay. Again, I think this one looks a bit okay. If I make my graph a bit wider or something, it can show the details. So the pink one is Australia, I guess the data from New Zealand, Australia, and also Pacific Island countries. Obviously, very concentrated around the high end, 80 years old. But if you look at the African data, it's very low, around 50, and also very the spread is very wide. And also the Asian data, on average, probably 70 something, but the distribution is very wide. Yeah. So for density, the geometry is called geom density, and then I just use alpha to make each density graph kind of translucent. Then I can overlay them. If you don't make alpha, I'm using alpha to make translucent, you get an ugly cover. The top one covers the bottom ones, right? Yeah. All right. And then you can even combine the histogram with a density plot. I do this only to want to show the capability of using ggplot. You probably don't want to do this in your graph, your assignment. It's kind of overdone. You don't overdone your cooking, right? So just make it just okay. Yeah. But technically, we can overlay different geometries in one graph if it's necessary, and then visually appeal. Yeah. Just be careful here, because I want to overlay histograms and density plots. I need to adjust my histogram. Remember, histogram is plotting the frequencies. Density plot is plotting the density curve of the random variable. If I just overlay histogram with density plot, the density will probably disappear, because usually the frequency value is very high, like 20, 30, 10, 15. So the observations in each group, the count is what called frequency. But density values, they are normally around 1, 0 point something. It could be high, 1 point something, but normally not like up to 20, 30. So if I overlay just histogram with density, you probably can't see the density plots because they are kind of squashed at the bottom. So what do? I'm going to plot the relative frequencies in the histogram together with the densities. What is relative frequency? That is the proportion of observations in each bar or each beam. So you have 20 people from 25 to 20 to 30 years old in the European group. Then the frequency is how many people did I say? 20 people? 25 people? Yeah, the frequency is 25. That's the value of the bar in the histogram. But the relative frequency will be 25 divided by the number of people in the European group. suppose there are 100 people in the European group, and then the relative frequency will be 0.25. Yeah. So relative frequency is just the group proportion. And then I can overlay the relative frequency histogram together with the density plot. To request the relative frequency, you just have to add this extra bit. Y equal dot dot density dot dot. Don't ask me why, I just the grammar. Okay. Yeah. If we try this one again, it should be working. Kind of complicated. Yes, it's working. So all the codes are working this part in this condition. This one should be working too. Yeah. Okay, almost the end. Just 11, we'll probably finish in 5 minutes, 10 minutes. The last one, I didn't put in title, but just I will show you some newer geometries that are available in ggplot2. This one is a violin geometry because it looks like violin. And this graph, I overlaid violins with boxes. So it looks like a, I know what it looks like. It looks like a Star Wars warship. Yeah, or stingray fish in the so this kind of violin geometry is kind of a new design and is available in ggplot2. But there are also many other new geometries that are available in ggplot2 packaged. It's kind of untraditional, but they're getting popular and more popular in the modern literature. So I can think of the violin geometry as a kind of variation based on density plot and box plot. Yeah. To give a try, sometimes it could be useful. So I use a violin geometry here to show the distribution vertically. A density plot is normally like horizontal, but this time it's vertical, and also left and right kind of symmetrical. And also I overlay the box plot on top of it to indicate the important like Q1, Q2, and Q3, first quartile, median, and third quartile. But obviously, this is probably not a perfect graph. You can modify it by doing something, maybe color or something. And yeah, I have an example. Yeah, I have example here. Yeah. So in your report, as Lydia said, in your report, we have to provide some professional graphing. So how to show the professional graphing, the details matters. The details like the label of the horizontal axis, the label of the vertical axis, give some meaningful label, and then like this one I said life expectancy in terms of years, not months, not days. Okay. And then don't just use a raw variable name because usually the raw variable names are not very meaningful for the readers. And then this, I can probably remove the background color, make it black and white thing. Because in the visual design theory, there's a famous person called let me Google. There's a famous person called Dafty. Can't remember. Is it Dafty or something? Yeah, there's a concept called a data ink ratio. Taffy, Edward. Taffy, I think he's a professor in the Netherlands or somewhere, European. And he has a few books. If you Google this name, Edward Dafty, he has a few books, very influential information books about visualization of data. Yeah. And then one of the concepts we propose is for the data link ratio. When we are using the visualization to illustrate data, the idea is just use the ink cautiously. Okay, when I color something, remember the color needs to have meaning. If the color is meaningless, maybe just don't color it. Like this graph, background is a kind of tint, and the bar color is kind of dark black. And what's the point of having a tint background? Does it mean something? If it doesn't mean anything, maybe just make it black and white. Well, it's just the kind of philosophy. Sometimes you want to make a data, make a graph kind of colorful, depending on the people you are talking to, the audience, the readers. Okay. Yeah. All right. Anything from Lydia?
Firstly, something you want to do with all your code is using comments effectively. So with something like this, for example, I would be doing like hashtag histogram, hashtag density, or whatever for all of them. So when you're coming back in future units, you don't have to try and figure out what you're coding. You can just be like, oh, here's my histogram code. I'll just copy and paste that, change the data labels. That's legit all you have to do. I don't think I've typed code in ages for plots. I think I've just copied and pasted for years. So yeah, make sure you do that. Also for your assignments, I really recommend using the assign. So be doing this for all your plots. It'll make it a lot easier than at the end. You can just run the plot itself instead of having to run each plot every single time. And then that means that you're not like constantly overwriting the previous plot. So it doesn't come up because so it hasn't overridden that one. And then let's say I want to print it at the very end, and then I just. So I definitely recommend assigning all the time. And then yeah, so up here for this, it would be this would be like the layout of the code.
Yeah, maybe you can name the plot one something more meaningful.
Yeah, something more meaningful, but sometimes when I'm experimenting, it's just like plot one A, plot one A, B, that kind of stuff. And then, so that's kind of how I lay out code in SCP 113. But as you're transitioning to other units where you're just using R rather than learning R, I tend to lay out my code in terms of my report layout, because the graphs should be something you kind of add in towards the end. So you should know already what you want to talk about. So I usually have a lot of the report, like my talking points dot pointed, and then I'll like sketch what graphs are going to be most meaningful. So I look at it, what I'm trying, like the point I'm trying to make, and then be thinking, do I want a histogram? Do I want a box and whisker? Do I want scatter plot? And then kind of think about that. And then, so my code will be like section 1.0, section 1.1, that kind of thing. So it's nice and easy to find. So use comments in your code to your advantage instead of just,
it just reminds me, Lydia, remember in the first week something we talked about comments, you can have a section title. So if I, like this one, you with a hashtag, you start a line of comment, and if you end the line of comment with 4 hashtag, you are creating, if you go to code, there's an outline. Show document online, this one. You see, you can see that if this one is a hotspot. If you end this line of comment with 4 hashtag, you're creating a subject or not subject. Okay. Yeah, subject on. If you don't want this one, you can just turn it on. But if you turn it on, you can quickly go to the bottom, but like 200 lines of code. you just scroll down, you get a sort of finger maybe. But if you create this kind of a document online, you can quickly navigate to whichever part you want. We mentioned this one in the second week, something hopefully people still remember it. Remember first bit. Yeah.
Could be worth even combining your notes from these workshops into one script and having it like that, where you just navigate. So you can be like, oh yeah, how do I install a package? Go to install package, or you can just find histogram and find all your code, practice code for histogram. But yeah, the code won't change, and if it does, I will tell you. So the stuff you're doing now, you can use like me 6 years later.
Well, that's the point, right? We learn something we want to use, not just something. Just past unit is important, not just past unit. Right? Yeah. All right. If you have any questions, you can linger on a little bit longer, and also people online, if you have a question, just yell out or type out. And otherwise, that's the end of today's session. And again, thank you very much for coming to the session. And then I will email you again, email everyone in the registration. And again, the links to the attendance and the feedback, and also a copy of the slides. It's recorded, so I will also email the link to the recording.